All right, today we are going to look at word problems that involve multiple expressions. So initially, some examples of when needing to solve a word problem with multiple expressions might come up could just be that two people are doing the same thing but at different rates, which is kind of the example that we're going to see below. Or two people are running the same race, but one person maybe gets a little bit of a head start. These are all examples where being able to compare using multiple expressions might help a bit. I've outlined a process for you here. You should define a variable, and the key is there really should only be one variable here, okay? In a lot of these, it might initially seem easier to define two variables. But if you define two variables, it becomes very difficult to do anything in terms of solving. The process becomes a little more complex, so we're going to try to stick with one variable. You are going to then write each of those expressions in terms of the variable. And then here, this is the part where we don't know exactly how you're going to combine them. Maybe you're going to add them together and set them equal to a total number. Maybe you're going to set them equal to each other, maybe something else. That's where you've got to use a little bit of logic and critical thinking. Okay. Um, so the word problem we're going to use is a potato peeling problem. I know, very exciting. I start peeling potatoes at a rate of 2 per minute, and then my wife starts 3 minutes later, but she's peeling them at a rate of 4 per minute. First thing we need to do is figure out what variable we want. There are only two really things in this problem. There's time and there's potatoes. We don't want to define potatoes as the variable, okay? Because we want to define, if you're familiar with the science term, the independent variable, we want to define that one, okay? So we want to define maybe t equals time in minutes, okay? And again, the way that you would decide whether to define the variable as time or potatoes, you want the independent variable, meaning the one that is going to change the other one. So one of the phrases I like to use is the number of potatoes peeled dependent on the time peeled? It is. Therefore, time is the independent variable and potatoes are the dependent variable. Okay, it doesn't make sense that, well, the time is dependent on the number of potatoes. That doesn't make sense. Time is the independent variable. Most of the time, if you have the choice, time's usually a good one to define. What we're going to do now is write the expression for the number of potatoes that Mr. Strains has peeled. I peel 2 per minute, so 2 times the number of minutes, or just 2t, if you prefer to be a little more concise, is the number of potatoes I've peeled. Here's where life gets tricky and where we may need to go up and redefine our variable. At first glance, it seems like Mrs. Strains would peel 4t for potatoes because she does 4 per minute. However, the key is that she starts 3 minutes later than I did. And we want to use the same variable. We don't want to use a different time variable for her. So we've got to find a way to adjust that. I'm going to go back up here and redefine time as the time in minutes for Mr. Strains. Okay, so the time that I've been peeling potatoes. Okay, so now my wife is 4t, but she hasn't been peeling potatoes for t minutes. Okay, she's been doing it 3 minutes less than me. So I'm going to change her time to be 3 minutes less than mine, or t minus 3. Okay, because that's the number of minutes she's been peeling, and that checks out, right? If I've been peeling for 5 minutes, that would mean she's been peeling for 2 minutes. Five minus 3. Okay, the number of potatoes peeled together then, that's just adding them together. 2t plus 4t minus 3. Okay, if they have been peeling for 10 minutes, how many potatoes did they peel together? Okay, you've been told that time equals 10. Okay, and again, I think the assumption we're making here is that's when I started, okay, not when my wife started. Okay, so we're going to plug in 10 for t and we're going to evaluate that expression. So we get 20 plus 28. That's 48 total potatoes. Okay? Cool. Now you've been told that 33 potatoes were peeled in total. Okay? So this is a little bit trickier, but here's what we're going to do. We're going to take our expression. Now, this expression represents the total number of potatoes peeled. Now, we don't know the time, but we know the number of potatoes. So let's set that equal to 33 and let's solve. Okay, I'm going to distribute and get 4t minus 12. Then I'm going to add things together. I get 6t minus 12 equals 33. I'm going to add 12. I get 6t equals 45. I'm going to divide by 6. Now, don't fret that this didn't go in evenly, okay? Even if it didn't go in evenly, you can definitely peel, potatoes for a partial number of minutes. That's totally okay. This is just 7.5 minutes, okay? Now, that unfortunately only answered that first part of the question. How long did that take? I now want to know how many did each of them peel individually. Okay, so this is a little bit tricky, but what I need to do is I need to plug in 7.5 for t into those expressions individually. So I would have peeled 2t potatoes. I'm going to change that to 2 times 7.5. So it looks like I peeled 15. Now, we could plug in 7.5 into my wife's expression, or we could just use a little bit of logic. 33 potatoes were peeled total. 33 minus 15 is 18. So I peeled 15. My wife peeled 18. Now, there's a small problem with the expression for B part 3. So actually, I'm talking about this right here. Okay, this expression represents the number of potatoes peeled combined, okay? It really didn't become a problem anywhere that we saw it, but there's actually, if you really think about it, there's kind of sort of a problem with that expression. I want you to think about that tonight and be ready next time we meet to talk about what the potential problem with that expression might be. Again, it won't happen in all situations, but in certain situations, there's a problem with that expression.